Hey guys, welcome to another studio workshop here from HOFA-College. This time in my control room, the control room A of the HOFA-Studios. Today we are going to talk about frequencies, frequency shaping, EQing, all that stuff. And I want to show you some nice techniques and some things that are really important to know when you are working with difficult words with frequencies and EQs. And yeah, let's start right away with some vocal EQing. Okay, here we are. I prepared a project in Cubase. It's just one lead vocal track and it's just a short example, and we start by listening to that track, just to that short clip.
Help me. It's like the walls are caving in. Sometimes I feel like giving up, but I just can't.
Okay, this is quite a normal vocal recording with a suitable microphone. It's been a Neumann as far as I remember, and there's nothing especially bad or especially good about it. It's a good singer and it's a good recording room and a good microphone, but it's not extremely loud or extremely high or whatever. It's just a soft vocal line from one song that we recorded for our college open projects. And I want to talk about the importance of the different ranges in instruments, in voices, in noises as well. And we have to differ between fundamental tone range and harmonics overtone range. And when you listen to that recording,
Help me. It's like the walls are caving in.
you can see in the analyzer that there are different ranges, and this range here around 200 to 300 hertz is a little bit louder than the upper frequency ranges. And this range is the fundamental tone range. And a lot of people know that word, but are not exactly sure what it is about and what this frequency range is really is telling. And I can show you that with some sine tones. And sine tones are tones like that. They have only a very narrow frequency range in which they sound. There are no overtones, no harmonics in a undistorted sine tone. And when I play the melody of that vocal line, you can see both instruments, the real vocals and the sine tone in the analyzer.
Help me.
Oh, sorry, that was wrong.
Help me. It's like the walls are caving in. Sometimes I feel like giving up, but I just can't.
And I played along with the vocals, and the vocals have a very wide frequency range in which they are active, but the sine tones only show the fundamental tones. And I played these. That are exactly is a range in which the fundamental tones are playing. And you can see they are in a very narrow range from below 200 to a little bit above 300 hertz. It's not exactly an octave, but close to it. And this range is so important for the sound of a voice, of an instrument. I want to show you that. Just let me check this one first. Have to turn this one off, right? So with this EQ, you can see it now, right? With this EQ, I filter off the high and the low frequencies and just show the fundamental tone range of the voice. And of course, this is not usable at all On the other hand, and I turn that EQ off again and show you the sound without the fundamental tone range.
Help me.
It sounds like this.
Like the walls are caving.
And that's not usable either. So when we talk about the different ranges in a voice, you have to know which frequency range you are talking about before you start EQing. And you think, I hear something, but I don't know what it is. Maybe I turn the EQ a little bit. You should know the fundamental tone range is a little bit too loud, or on the other side, the harmonics are a little bit too quiet. And you can see that in the analyzer. And the analyzer is a very helpful and useful tool for this. And when you look at the complete frequency range in the analyzer,
me. It's like the walls are caving in. Sometimes I
you see
feel like
and you hear that the fundamental tone range is a little bit louder than the harmonics. So maybe you could say, I turn up the harmonics a little bit, and you can use the different bands and curves from an EQ for that. And for example, the overtones and the harmonics are often in a range above the mid-range. They start in the mid-range, of course, but that what we think of as harmonics are often a little bit higher than that. And
help me.
For example, I turn on this EQ. That's pretty strong boost of the overtones now.
Help me. It's like the walls are caving in.
And this shelf EQ adds a lot of high frequency, but it starts already in the mid-range. And that is a very nice, useful technique to add some brilliance to the sound and to make it more punchy in the mix, like it cuts through the mix better with a stronger overtone and harmonic range. On the other side, the fundamental tone range, which is a little bit too strong here, when I turn that down,
help me. It's like the walls
it starts getting thin. So you always have to watch out when you are EQing and when you're using frequency ranges to get a nice balance between the fundamental tones and the harmonics. There is also the mid-range, which is really important in most acoustic instruments and vocals, where all the natural sound elements are located. And that is often, depending on the range where the singer is singing, somewhere here.
Sometimes I feel like giving up, but I just can't. Help me.
So this range is really important that you keep it in your mix and you keep that frequency range audible, or otherwise the sound will get very technical. If you, for example, start boosting the overtones, the harmonics, the treble range, and cutting down the mid-range, you get a sound like that.
It's like the walls are caving in. Sometimes I feel like giving.
And that is what we often talk about as a bathtub curve or a banana curve or whatever, when it's scooped in the mid-range and boosted in the high and maybe even the low frequency ranges. That is really important that you understand these ranges and you not listen, there's something wrong and I turn it in and I don't know what it is, but it sounds better after it. But you understand the different functions and roles of the different ranges in a signal, and then you can start EQing. And I want to show you that with the next example that I prepared. And yeah, just let me switch my project now. Come on, where is it here? Okay, you want to see the complete window like that, really? Okay, here we go. So let's start with a real EQing, not just like theory and physics. And I want to show you an EQing technique that is really important in most of the mixes I do. And that's really an essential technique when you want to keep a sound balanced and natural and yeah, well controlled. First thing though is that in my opinion, and that's what I wanted to show you with this project too, that before we start mixing and EQing and using plugins or real hardware EQs or different tools to shape the frequencies, the most important thing, especially when you're recording acoustic instruments or vocals, is happening before the mix. The sound is already shaped and yeah, decided about in the recording process. Which microphone do you choose? Which position for the microphone do you choose? And maybe even which room and which distance from mic to singer, which characteristics from the microphone. There are so many things you have to decide in the recording process that change and shape the sound of the instrument, that you should really always have these possibilities in mind and not think, maybe it sounds a little bit dull, but I can fix that later in the mix. Always, if you have an impression about a sound in the recording process, try to make it as good as possible in the recording and not to turn it on later in the mix. So, okay, there was a live chat. MPL Corsa is happy that we're providing these live streams. I'm glad too that we can be here with you. So, all right, let's listen to these tracks for a few seconds. That's an acoustic guitar. That's an example that we did with the same acoustic guitar pattern, but we recorded it again and again with different positions of the same microphone. It's a Neumann M149 with different positions, distances, and also, no, it's always always cardioid characteristics. So, and yeah, let's listen to that. Now a switch. The next one. Another one. So you can probably hear that it's always the same guitar and even the same microphone, but still you can hear there's a lot of difference between the different positions. And this is not a recording workshop, don't worry, but it's very important to me to tell you, keep an eye or even better an ear on the sound of what you're recording in the recording, and don't think I will use all those great EQs I have in my software and make it better in the mix. Try to make it as good as possible in the recording, and then you can really start making the sound and defining and adjusting the sound in the mix. So I chose for one of these recordings for this project now, for this workshop, and gonna show you some things I would do in a real mixing process depending on the things that are around. This is just this one track, but you always have to keep in mind that when you are using EQs in a mix, don't do it always in solo mode. You always have to listen to all the instruments together to really decide about the final sounds. Of course, you have to sometimes switch into solo mode because you have to hear in detail what you are doing, but you also have to hear it in the context, in the musical, entire mix, and hear it with all the other instruments. So this is the project, and where's my EQ? I lost it. Here it is. So there we go. Always on top. Now it's better. Okay. This is a so-called dynamic EQ. I think some of you are familiar with that, and some are not. But I think it's a really, really important tool when you are mixing and when you are working on frequencies. The first band of this EQ is a normal low cut. That is something I would suggest to do in any case it's necessary, but don't do it in general. If it's not necessary to use a low cut, do not overdo it. Sometimes it's taking away too much of a sound, especially if you are not really working with an analyzer, and maybe taking away something of the fundamental tone range. And I told you before with the vocals how important this fundamental tone range is. So I think this low cut is set in a way that should be not making the sound thin or without body. So just let me just use the low cut. You can see the fundamental tone range here is still there. I'll make a snapshot of that. Turn off the filter. So you can see there's some noise happening in the low end, and there's a little bit of rumble and sub-bass frequencies. That would be a little bit annoying in the mix, especially if you're using some compression or limiting. You have to get rid of that noise in the low end, and that's the best to use a low cut. Don't overdo it. Just filter the frequencies that you want to filter and nothing more. If I turn this frequency too high, it was on 75 and now I turn it on 375. And almost everything of the instrument is gone. It sounds thin, it sounds technical, it doesn't sound like a real natural instrument anymore. So be really careful with your low cuts. So the next band here is the typical resonance of an instrument, of an acoustic guitar, that every acoustic guitar has a resonance in that range somewhere around 200 hertz. If it's a big guitar, this one was a large Gibson Jumbo, it's a little bit lower. If you have a small guitar or a ukulele or whatever, it's a little bit higher, but every acoustic stringed instrument has that resonance, that body resonance. And this one is around 170 to 200 hertz. You can see it in the analyzer and just look at it when it's happening. This one. And of course, I could start by reducing that frequency, like really heavy. Then it's gone, but also the sound starts getting thin all the time and not just in that few spots when this resonance is happening. And that's where a dynamic EQ comes into play. That's a really nice and useful tool to use on acoustic guitars very often, but also on vocals, on pianos, drums even, and other instruments. It's a great tool. So I switch to dynamic mode and make the reduction, the static reduction of that band a little bit less, and then set it to look ahead. That's important. So this way the analyzer in the EQ can see and hear the frequencies that are going to happen in a few milliseconds and turn it down a little bit before they actually occur. So it's going to be much smoother and less audible EQing. So I'm going to show you this here in the EQ. You see it a little bit better. So now you see, let me overdo it a little bit. I turn down the threshold. Then it's working all the time. That's way too much. So back to the original state. Here it was working, here it is working again. And that's a great tool to get a balanced and natural sound. You can see it in the analyzer. The peaks are gone in this frequency range, but still the energy and the overall sound is not getting thin, and it's not the energy is not lost, and it's still there. And so you can always work on frequencies that only sometimes come up, and like resonances, they are not here all the time, but they come up when that chord is played or when it's played louder or whatever. And then a dynamic EQ is a great tool you can use for those purposes. So I think I'm done with that dynamic EQing chapter, and let's hop on to the next one. What is that? Yeah, that's a nice one. I like that. Let me switch the project. So here we go. Set the analyzer. Okay, this one is not a real instrument. You can see in the project that it's programmed, or no, not programmed. It's a played MIDI track, and it's playing a sampled Rhodes instrument in the contact player. And that's what it sounds like without any processing. So, and that's about it. That short little example, just to show you something that is, for me, a really nice, although basic, but really nice tool for balancing sounds that are nice and sound cool, and there's nothing wrong with the sound, but still it won't work in the mix like that. And it needs a little bit more, present range, and it needs to be less strong in the low mid range, because it's a little bit too warm and nice. It sounds great alone, but as soon as you play a guitar, a drum, set, and there are vocals and also a bass and a bass drum, and this sound will get too dull and it will sound very intransparent in the mix. So you can use one tool that I really like, that is this one. It's a so-called tilt EQ. But where's my analyzer? It's gone. It's gone. Bring it back. Here it is. So, okay, always on top right. So, hope you can see it still. Yeah. Okay, let's get back to this tilt EQ. A tilt EQ is doing exactly what the name suggests. You tilt the sound from one character to another, not like working in detail on one frequency and just reducing one resonance in the sound, but when the sound is a little bit off balance and it's a little bit dull, you can say, I make it brighter and a little bit less strong in the low end. And you can see the curve this EQ is making. Let me turn off this high cut for a moment. And then you can see when I'm doing this, it's it is like tilting the sound from one character to another. And you can move this frequency, and the way the EQ reacts is very easy to understand. And it's like something that old radios had in the 30s and 40s of the last century, or that in many amps, guitar amps have, like a tone control when you make it from warm to bright, stuff like that. All these EQs, or some of these EQs, been doing exactly this, tilting the sound from one character to another. So that one's been a little bit too much, so I undo all this stuff. Okay, here we go. I turn it on. No, first without. Now turn it on. Make it a little bit more. Okay, that's too much, of course. And the great thing about it is that it still sounds balanced as a whole instrument if you're not overdoing it. And it's just like yeah, I love Rhodes, I do. And yeah, it still keeps the character of the instrument, and it doesn't make it into turn it into another instrument or turn it into something that doesn't sound authentic, but it still sounds like a Rhodes, and the sound is just tilted into a new and nice direction. I love doing using a high cut on that one, because it get rid of some noise, if there's any, in the high frequencies, and it also makes for a softer roll off in the high frequencies. And you can even do something we did in the project before with the acoustic guitars, and use it as a dynamic tilt EQ, and just if there are any notes that are too loud in the low range, for example, or any ranges that are a little bit need to be controlled, a dynamic low band can be very, very useful. Whoops, go back here. So, where is it? Here we go. I exaggerate a little bit. That's too much, of course. Makes no sense. Just a little bit, like 2 or 3 dB. And it still sounds balanced and nice. Just let me make a short snapshot of the frequency curve without that EQ. So let's see, orange line now is a version without any EQing. Now let's turn on the tilt EQ. And you can see that the curve is exactly showing what we can hear. Let's go down with the analyzer a bit. Then it's that there's not like a complete different way the curve looks like, but it's just a more a little bit tilted to the top of the frequencies, and the bottom frequencies, the low end or the low mid range is cut a little bit. And that is a reason that this EQ is working so great when you have an instrument that sounds nice in itself, and that there's nothing wrong with it and no resonances, but it need to be tilted into another direction. That's what it's great for. A second tool for frequency shaping, that's not exactly an EQ. That's one thing I want to show you now. And you probably seen this thing before. It's a so-called saturator. It's using saturation, distortion in a way, that is produced in original by different tools. There are cubes that are very popular for distortion, but also you probably heard the term tape saturation. Old tape machines used to produce great saturation with nice harmonics. You can use even condensers and other tools and other amps for creating saturation. In my case, I very often end up with a tape or a tube saturation. In this case, I decided to use a so-called thermionic. It's an old, I don't know exactly what it was. It was not a tube, but you can read it in the manual, of course. And you can see the way it creates harmonics. This is the fundamental tone, and these are the harmonic. And this saturation is creating a very nice and soft curve of the different harmonics. I don't want to talk about the technical background and the physical and theoretical background of harmonics, but this curve is really nice, and other looks maybe like this, just one overtone, or like this, like this, with a very diffuse and high range of overtones. Let's go back to the one I chose before, the thermionic, and listen to the version first without the harmonics. That's the one with a dynamic EQ. And now I turn it on. Oops, sorry, wrong button. Now I turn it on. It's still rather subtle. Maybe a little bit more. Now it's starting to sound distorted. You hear the crunch. Without. There's also a little bit of a tone control used in that one, but the main thing is, which is happening, is these overtones are added to the sound depending on the way we are driving the input. And you can see this as well, of course, in the analyzer. Where is it? Oh, come on. Okay. You remember this orange curve is the one without any EQing. Now let me make a snapshot of the curve with a tilt EQ. Okay, and now I add the saturator. Come on, here we go. Here we go, and now I make this one really big now that you can really see what I'm talking about. So, okay, just let us compare these two curves. No, these three. The orange one is the original curve. And you can see the mid-range level is exactly staying the same, but this sound range is much quieter by a few dBs, 3 or 4 dBs in that range here, and there are added like 4 or 5 dBs of the present range of harmonics, of high range, if you want, like call it that, and still it's not getting louder or more. A little bit more aggressive maybe, but it's still doesn't get in your way and doesn't sound like an unnatural instrument. And that's what I like about adding harmonics to the sound. If you want to get a real amp sound out of it, you can use a little bit more saturation. If you just want the color, you can use only a little bit. So let me play around with that just for you to listen. Rather subtle. A little bit more. Now it's starting to sound like a saturation. Now it's a little bit over top. And then you can hear it's not a real tube amp or whatever. It's like another tool. I'm not sure what it is. Thermionic. I should have looked that up before I talk to you about that. But still, you can hear what this thing is about. And saturation is a nice way to add harmonics to signals. It's really used a lot in the last years in a lot of mixes, not only to get a distorted sound, but to get a nice coloration of a sound, to make digital signals sound more analog, to get a more gluing between signals, but also to shape the sound of the overtones and to add overtones and thus brilliance and also a certain edge and a nice tone to instruments that could sound a little bit boring without that. And that's why I love using saturation for frequency shaping. So that's been this project. Let's move on to the next one. Here we go. Now the analyzer is way too big. Just reduce it, clear it. I don't need that. So, okay. I have a vocal track again, and I just want to show you a combination of different techniques. And yeah, like every part of it is adding something to the sound or taking away something if it's necessary. And yeah, just listen to it. You know the singer, we heard him before, and it's from the same recording. It's just the chorus part of that recording.
Help me. It's like the walls are caving in. Sometimes I feel like giving up. No medicine is strong enough. Someone help me. I'm crawling in my skin. Sometimes I feel like giving up, but I just can't. It isn't in my blood.
Yeah, you can tell that there are a lot of different situations in that part. There's a rather soft beginning of the chorus with a rather strong fundamental tone range, and then it's getting louder and louder, and in the end is really there's a shouting part. And something you should do in cases like that, you should split those tracks and make different channels for it. In this case, I used 3 different channels for the different parts: a soft part, a louder, and a chorus loud part. And that's what we're looking now is the chorus, the louder setting. And yeah, that's what it ends like sounding in the end. The complete signal chain.
Help me. It's like the walls are caving in. Sometimes I feel like giving up. No medicine is strong enough. Someone help me. I'm crawling in my skin. Sometimes I feel like giving up, but I just can't. It isn't in my blood.
Okay, make a snapshot of that, and then we again listen to the
Help me. It's like the walls are caving in.
First problem here, the intro, the first phrase is very quiet, very low MIDI, and the next line is rather quiet and not as powerful in the low mid range, and so it doesn't sound balanced. And this phrase then,
sometimes I feel like giving up, but I just can't.
you can hear the word like. That's very loud, and it's looking out of the complete context with a very thin frequency around 800 hertz.
Sometimes I feel like giving up, but...
And that's something we have to get rid of. And so, of course, we can talk about compression, but it's not only that. We need some dynamic processing, but we also need dynamic frequency processing. And that's what is happening here. The first plug-in in the line is this EQ. It's not doing very much. It's just, acting as a boost in the high mid-range and the overtones.
Help me. It's like the walls are caving in. Sometimes I feel like giving up. No medicine is strong enough. Someone help me.
Okay, so that's not enough to get rid of the low mid-range, and I just see I haven't done the real processing at all. There was some important part missing, the dynamic processing of the low mid-range.
Help me.
And that's what's happening here.
It's like the walls are caving in. Sometimes I feel like giving up. No medicine is strong enough. Someone help me.
And now you can see and you can hear that it starts getting much more balanced and stable. And the thing is, and that's why the reason why I forgot to turn this off, I wanted to show you the effect this dynamic EQing has on the compression. I turn it off and take a look at these two compressors working in a chain. The screen is too small for that. So, okay.
Help me. It's like the walls are caving in. Sometimes I feel like it.
So you can see the compressors have a lot to do. If I use that dynamic control of the low mid-range.
Help me. It's like the walls are caving in.
There's a lot of work that's been taken away from the compressors. And just for demonstration, I want to show you what's happening if I turn in the bass range in the vocals.
Help me. It's like the walls are caving in. Sometimes
the compressor has to work much more, and it's it's getting audible, and the compression is starting to sound really muddy and dirty and not nice at all. So you have to always remember when you do EQing that it affects every dynamic plug-in that is inserted after the EQ. So like these two compressors, they are affected by the way the EQ is working. And that's the reason why a strong boost in the low end has to be done very carefully, always with an eye on the compressor. And if you change something on a frequency band that's before a compressor, you have to really look carefully on the reduction, in the gain reduction on the compressors. So bring it back to normal, and that's the way it was.
Help me. It's like the walls are caving in. Sometimes I feel like giving
that
up.
sounds pretty good like that. And after the compression, I use a saturator in that one because I checked myself the original mix of that song, of course, but I also wanted to have a little bit of that nice overtone range that is coming up when you use a saturator. And for this one, I used the really rich frequency range that is added by this germanium saturation mode, and that's the way it sounds with the saturator.
Help me.
Or without.
It's like the walls are caving in. Sometimes I feel like giving up. No medicine is strong enough. Someone help me.
And again with.
I'm crawling in my skin. Sometimes
you can hear there's something added on top of the vocals, and it's just like not only shaping the frequency range a little bit, but it's also dynamically compressing it a little bit. A saturation is always not only changing the frequency range by adding overtones, but it also making for a soft or less soft compression if you're doing it a little bit stronger. So, and that's for me a nice combination of frequency shaping elements like a basic EQ in combination with a compressor or two compressors in this case, which always have also effect on the frequency range and the result, and additional saturation in order to get a nice harmonic overtone range that is really adding something to the original sound. So let's compare the unprocessed version.
I'm crawling in my skin. Sometimes I feel like giving up.
with a processed version, and yes, there is some reverb on it.
I'm crawling in my skin. Sometimes I feel like giving up, but I just can't.
It sounds more stable, it sounds more balanced, and it sounds a little bit richer in harmonics and richer in the nice, brilliant presence range that is important for a lead vocal track to cut through the mix, to stand in front of everything, all the other instruments, and that's a good way to get there, using dynamic EQing, using compression, and using saturation. So that's it for this project. Let me get to the last one I prepared. And yeah, I prepared something that is not actually using EQs, at least not as a main tool for frequency shaping. I want to show you a good way to process and to work on the frequency range of drums, of percussive sounds, because in drums it's often not always useful to work with static EQs that have the same setting all the time. For example, if you have a snare drum that is divided in different parts of the sound, the attack often needs to be really hard and punchy, then need to be nice transients to have a good punch in the mix. And then there's a decay phase or the sustain, and that can be very different in different snares. Some have only like a poof a little bit after the attack phase, and some have really a nice, or sometimes not so nice, ringing, like boing, that can be nice, can be a little bit over the top. I prepared a short phrase of a drum set that is using a snare that has a little bit of that ringing. I just show you. So, and there's not happening very much yet in the mix. Just let me check the mix for a second. Okay, you can see there is this EQ on the bass drum. I'm not interested in the bass drum now, and the EQ and the transient EQ. So let me turn this stuff off. The limiter is just for safety. That's not doing very much. Just show you. So just a protection. There's no reduction. So just let me show you the snare in solo mode. These are 2 channels. And that's a very nice and natural snare sound, but it is a little bit, yeah, I don't want to say boring, but it still needs a little bit more punch and attack. And maybe even we need to get rid of the boing. Sometimes I get a little bit, bored by that sound, and that's a little bit annoying. So the first thing to do is, if you look at the frequencies without any EQing, let me check the analyzer, it's clearer with that. So here we go, here it is. Again, we have to divide the signal into different ranges, and this frequency is a fundamental tone, and this is a harmonic or overtone, and this one is much louder than the harmonic, and that's something I don't like in a snare. So that's why I get rid of or reduce it a little bit, this frequency in the harmonic range, and boost the fundamental tone range. And it sounds like this with EQ and without. You can hear that there's a little bit more power and more body added to the sound, and that's what I like in a snare. It shouldn't sound too thin. And the next thing I want to use is this one. That's a transient shaper designer tool, whatever you want to call it. It's our plugin. It's called the IQ Series Transient, and it's adding, or it's enhancing the transients, but in this case I want to use it not to enhance the transients completely in the whole range, but to especially boost it in this range here. That's especially necessary and important for the attack of a snare sound. And yeah, just let me show you this. Okay, I turn it on a little bit more. So that's too much. Going back. And this frequency here is boosted more than the rest. And just in the moment the transients are needed. So let me boost this even more. The good thing about this that this EQing is only happening when we need the transients to be there and edgy and aggressive in the mix, and when the transients are gone, this boost of the high frequencies is gone too. Without. And we can understand that there have not been very much transients in the original signal. I'm exaggerating, and it's too much, of course. But something like that would be just fine in the mix. And on the other hand, if I want to get rid of that maybe annoying boing, I can use the sustain control in the mid-range. That's too much for me now. Make a little bit less. No processing and transient processing. So you can see that processing the frequencies differently in different stages of the envelope, attack, decay, sustain, you can really make create sounds that are not possible when you're just using static EQs, like turning in the presence and cutting the mid-range in a static EQ will have not the same effect as this one. We get nice transients, we get less sustain, less ringing, or less boing, if you want to call it that, and we have, in the end, we get a very nice drum sound. Let me turn the other stuff on as well. Sorry. And we can turn off all the plugins at once, all the inserts. No, all the EQs, of course. That's the way it sounds without any EQs and without those transient EQs. And that's the way it can sound with a not finished mix, but with just added transients to the snare, reduced sustain of the snare, and make it more punchy in the mix. That is not a final mix, it's just an example what you can do with the frequency functions of a transient plug-in, and that's really another way to use dynamic EQing in a way, because it's only working when it's necessary, and it's doing nothing when there is no need for it. And that's what's really fascinating about dynamic plugins like transient plugins like dynamic EQs. You can use them not only to change the envelope and the dynamic behavior of instruments and sounds, you can also use them to to change the frequency response of an instrument and to affect the whole frequency sound of a mix. And that's there's much more to EQing than just using static EQs. And I think that's about it. And I think I'm pretty much in time and exactly to the point where I will conclude this workshop. If you want to find out more about audio engineering and you are not already registered at HOFA-College, take a look at our website and find out what we can do for you. So that's it for today. See you next time.